All right, this week we're going to take a look at combination circuits. I'm going to show you how to do one of these. Today's page is like an intro into complex circuits. I've posted on Canvas a link to a web page with some instruction on combination circuits, but I'm going to show you quickly how to do one. And maybe you can pick it up just from watching this video. If not, please read the web page that I posted on Canvas. All right, so I'm going to do this first example here. Right on top, it wants you to find your equivalent resistance or your total resistance in parallel. We're going to do that here with this one. So I just copied this example over so we have some more space to work with. And I also made our charts because I think it's important to stay organized. So on the page, it's asking to find your total resistance, your total current, and the current down each part of our circuit. But I'm going to just fill in the rest of the chart too, because we're going to have to do it later this week, so we might as well do it on this example. So we have our circuit here. It's got 12 volts, it's got a section in parallel, 2 branches, both 4 ohms of resistance. And then we've got our 2 ohm resistor that is in series with the rest of our circuit. So if I were to read my current here, right, that would be my total current of my circuit. If I was to read my current here, that would give me the current just down that branch. So we have to be careful. We are going to use our rules for series and parallel, but we have to pay attention to what part of our circuit we're talking about when we use all of these rules. So first things first, we're going to find the total resistance of this circuit by simplifying our circuit. So I'm going to find the resistance just of this section here, and I'm going to simplify our circuit. So if I pull this section in parallel out and put a different resistor in there with the same equivalent resistance, it will behave the same way that this section in parallel behaves, and it will make our math a little bit easier because we'll be in series. So I'm going to find just the resistance for this section using our equation for resistance in parallel. 4 gives me a half, and I need to take the reciprocal of a half, which gives me 2 ohms. So if I were to take out this section in parallel and put in a resistor of the same resistance, it would end up being a 2 ohm resistor. Now we're in series and we can follow one set of rules. So in series, I add up my resistance for my total resistance. So 2 plus 2 gives me a total of 4 ohms is my total resistance for this circuit. And with this, we can find our total current. So using Ohm's law, I will do the 12 divided by 4 gives me a current of 3 amps. I'll put that in my chart. So if I were to read right here, it would read 3 amps, but I know in parallel and it will add up to equal 3. So the current down this branch plus the current down this branch is going to be equal to 3. Since on this particular circuit the resistances are even, I know that my current is going to be cut evenly in half down each branch, but sometimes there's a different resistance down each branch when you're in parallel. So I'm going to show you how to do the math to find your current down this part of your circuit. So we only have our one variable out of 3, so we need to get our voltage used down this part of our circuit. So in order to do that, I'm going to calculate my voltage drops over these 2 parts of our circuit using Ohm's law. So B is I times R. So my current is 3 times my resistance, which is 2, gives me a potential difference of 6 volts. So I started with 12. I used up 6, I'll have 6 left over down this part of my circuit. I'm going to use up the other 6, leaving me with 0 volts when I go to the negative terminal of my battery. So I can say that my voltage used by this 2 ohm resistor is going to be 6 volts. And while we're here, I can also say that my current through this resistor, because this resistor is in series, is going to be equal to the total. So I should have put that in there earlier. Back to my section in parallel. I have a voltage drop or a potential difference of 6 volts over this section in parallel. And we know that our volts stay the same when we're in parallel. So I'm going to have 6 volts going down this branch and 6 volts going down this branch while we are in parallel. So I can put 6 volts and 6 volts. And going back to our original circuit, I can find our current down each branch using Ohm's law for just down this branch. So if I've got a voltage of 6 volts, a resistance of 4 ohms, I'm using 5.2 amps down this branch, and it'll end up being the same down this branch. But like I said before, this is cut evenly, so we didn't have to do that math for this one, but it is good to see the process. And then last but certainly not least is our power as I times V. So 6 times 1.5 will give me 9, 9, 18, what is it, 36. There we go for the circuit.